I'd like to take a moment now and talk about testing the system. I realize in the real world, if you guys were going to test a multiplexing system, you would just plug into your DLC. And with your DLC, you hook up to your laptop and you'd be able to pull your codes or faults and see what's actually happening in the system. But let's run a scenario that perhaps one day you may get out to a vehicle and you don't have your DLC with you, or probably you don't have the right software to connect to the vehicle or the manufacturer you're dealing with. So there are a way we can do some testing and see what's actually happening in the system. Of course, the first thing we always want to do when we do any testing is make sure we have adequate source voltage. So I'm going to turn my meter on to DC volts, and I'm going to check my source voltage. In order to check the source voltage on a multiplexing system, I'm going to go into terminal A, which is my ground, and I'm going to go into terminal B, which is my fused power, and it will give me my source voltage. So you can see I've got about 13.8 volts on this system. So theoretically, that tells me I don't have an alternator or battery issues. I've got an adequate voltage supply to run the system. So other tests I can actually perform, I'm going to move my lead up to the KMO, which is a D terminal, and I can actually measure the voltage happening in my low side of the multiplexing system. Now, you'll notice that I got 2.5 volts, and it's ranging from what, 4, 5, all the way down to 3.7. And one of the things that always comes up is, why is it doing that? Well, that's showing you the system is actually communicating. And now, even though I haven't got anything turned on, there's always some communication going on. It's just basically sending out a signal saying, each of the ECUs is saying, I'm here. And everybody knows everything's up and running. The other thing, of course, I can do is move to the CAN high side. And again, I can check my voltage. So you can see I've got 2.556, and it's communicating in the system. Now, that tells me the system is, again, functioning correctly. The other thing now I can do is actually check my terminating resistor. Now, we've always taught you guys that you should never take your own meter and put it into a powered circuit. So I'm going to take the power away, and the system will be actually de-energized now, and I'll get rid of any of the voltage in the system. I can now take my meter and move over to the ohm setting, and I'll go in the CAN high and CAN low. And you can see I'm getting a 59.1 ohm resistance. So remember, there's two terminating resistors, each one's 120 ohms. Two terminating resistors in parallel should be about 60 ohms. So I'm showing I'm actually fairly good on that side of the system. The other thing you can actually do, because I'm using the reference voltage about 2.5 volts, I can actually do it powered up. So I'm going to put power back in, and you can see I'm staying right around that 60 ohm resistance. Again, it's fluctuating a little bit because of the communication in the system. Now, I just want to show you quickly before we go back. I'm just going to put my ground back in the system. I'm going to go back to voltage, and you can see the communication. Now I'm going to actually start flipping some switches, and you can actually see how the communication actually starts to change as I start putting a load on the circuit. Okay, so you can see how the communication is changing as I put a load on the circuit. So that's just showing you there's more communication happening in the system. So there's a way I can actually take a meter and I can go to my DLC and see what's actually happening in the system if I'm not able to hook up to my laptop.